In this situation, we're being told that J is the right angle of our triangle. So let's label that. The right angle here is J. The cosine of K, let's just call this K and this L. The cosine of K is 29/51. So let's just think about SOHCAHTOA. And the cosine is the CAH. That's the adjacent over the hypotenuse. And that's 24/51. So let's find angle K here and go straight out, and that is the opposite. Then we'll go straight across from the right angle, and that's the hypotenuse. And last but not least, we have the adjacent side left over. And we were told that the adjacent over the hypotenuse is 24/51. So let's call this 24, and let's call this 51. Now, if we need the cosine of L, that's going to be the adjacent over hypotenuse from that perspective. So let's just redraw our triangle. We still have the 24 here and the 51 here. But this is our theta now, which makes this the opposite. The hypotenuse never changes as you go from thinking about one angle to the other, and the adjacent is now here. So when you take theta and move it from one angle to the other, the opposite and adjacent switch places. So if we need the cosine of this angle, in terms of SOHCAHTOA, we need adjacent over hypotenuse. In other words, we need the length of LJ. So let's put this into Pythagorean. A squared plus B squared equals C squared. The C squared is 51 squared. So we have 24 squared plus X squared, let's say, equals 51 squared. 24 squared is 576 plus X squared equals 51 squared, which is 2,601. Take away the 576 from both sides, and we get X squared equals 2,025. Now take the square root of both sides, and we get X is 45. That's the length of LJ. So what is the cosine of L? It's the adjacent over hypotenuse from the perspective of L, and that's 45/51, which can be simplified to 15/17, although the SAT does accept unsimplified fractions.